Similar to a linear equation, y equals mx plus b, a quadratic equation has two variables, x and y. But unlike a linear equation, at least one of the variables is a square. In linear relationship, the exponent is 1. In a quadratic, at least one of the variables is a square. As the name indicates, a linear equation, when plotted, forms a line. On the other hand, a quadratic equation, when plotted, forms a curve. The quadratic equation we'll study here doesn't form just any curve, but a curve that is symmetrical. Half of the curve is the reflection of the other half. Called a parabola, it is the shape of a path of a baseball or projectile in flight. The solution of a quadratic is achieved through factoring. If we remove the equal sign and the y variable from the quadratic, it becomes the kind of trinomial we covered in section 7.5. For example, x squared minus 2x minus 8 can be factored as x minus 4 times x plus 2. Putting back the equal sign and the y variable, it becomes y equals x minus 4 times x plus 2. This is the type of equation to be solved in this section. Because these equations represent curves, and curves come around, unlike the straight line of a linear equation that crosses axis only once, in many cases a curve must cross the same axis twice. A parabolic curve always comes back, like a boomerang. Notice how in the graph it comes down from left to right and crosses the x-axis twice before going off to the top right. Specifically, notice how the curve comes down and crosses the x-axis at -2 and comes back up crossing the x-axis again at +4. Factoring a quadratic equation, it is these very points we want. These points becomes the roots or zeros of the quadratic. The equation plotted in the previous graph is y equals x squared minus 2x minus 8. Because the value of y is 0 when the parabola crosses the x-axis, we now set up the equation equal to 0 to find the specific values of x when the curve crosses the x-axis to find the roots. 0 equals x squared minus 2x minus 8. Factoring the trinomial, x minus 4 times x plus 2 equals 0. Because it is not known which one of the two binomials, x minus 4 or x plus 2, is equal to 0, setting up each binomial equal to 0 is the way to find both values. X minus 4 equals 0, x equals 4. Or x plus 2 equals 0, x equals -2. These answers are called the roots of the quadratic and can be verified in the graph. Another example. Solve x plus 2 times x minus 3 equals 0. X plus 2 equals 0. X equals -2. Or x minus 3 equals 0. X equals 3. Another example. Solve 1/3 x minus 2 equals 0. 1/3 x equals 2. X equals 6. Or 2/5x plus 3 equals 0. 2/5 equals -3. X equals -7.5. Another example. Factor trinomial. What two numbers when multiplied yield a +12 and when added a +7? 0 equals x plus 3 times x plus 4. X plus 3 equals 0. X equals -3. X plus 4 equals 0. X equals -4. Another example. Move 2 to the left side and add to -4. X squared minus 5x minus 6 equal 0. Factor. What two numbers when multiplied yield negative 6 and when subtracted negative 5? X minus 6 times x plus 1 equals 0. X minus 6 equals 0. X equals 6. X plus 1 equals 0. X equals negative 1. Another example. Move negative 9 to the left. This is a perfect trinomial square. X minus 3 times x minus 3 equals 0. X minus 3 equals 0. X equals 3. X minus 3 equals 0. X equals 3. I have graphed the quadratic to show what happens when both x's are the same. You get one double equal root, this time at 3. This curve comes down and instead of crossing the axis, it just touches it. Another example. Move 6x to the left. Find common factor. In here, one of the x's has no value. X equals then to 0. In the other x, x minus 6 equals 0. X equals 6. Another example. Factor. 2x plus 5 equals 0. 2x equals negative 5. X equals negative 2.5. X plus 2 equals 0. X equals negative 2. One last example. Move 12 to the left. Factor. 2x plus 3 equals 0. 2x equals negative 3. X equals negative 3 over 2. 3x minus 4 equals 0. 3x equals 4. X equals 4 over 3.